Hello, this is Dr. Johnson. I'm one of the AP Stats teachers at Capel High School. Welcome to today's lesson on sampling and surveys. You should be following along with the note-taking assistance sheet that I wanted you to download. That should help you identify the most important parts of today's presentation. First of all, I want to distinguish between populations and samples. A population is the entire collection of items or subjects about which we want information. A census occurs if we collect data from every item or subject in the population. This can be very time-consuming and very expensive. So we often do a sample. A sample is a subset of the population from which we actually collect data. Here's an example. Suppose Gallup took a sample of 1,500 adults in Texas to see how many bought a lottery ticket last year. The population, all adults in Texas. The sample, the 1,500 adults who were sampled. I also want to distinguish a parameter from a statistic. A parameter is a number that describes a characteristic of the population. It might be the true proportion of Texans who bought a lottery ticket. A parameter is usually a fixed number or moves very slowly, but in practice, we don't know its value unless we take a census, and that's very expensive. A statistic is a number that describes a characteristic. We know the value of the statistic as soon as we take that sample. The value of the statistic will vary from sample to sample, and we often use a statistic to estimate an unknown parameter in the population. That's called inference. Inference is the process of drawing conclusions about a population from what we know of a sample. A sample is only generalizable to the population from which the sample was selected. So, the results of a random sample of CHS students can be generalized to all CHS students, but the results cannot be generalized to all high school students in the US due to differences in geography, demographics, etc. Bias. The design of a statistical study is biased if certain responses are systematically favored over others. When you claim a study is biased, you should state whether the sample result is likely to be too high or too low compared to the true population value that we're trying to estimate. One technique of sampling is called the voluntary response sample, and this leads to voluntary response bias. A voluntary response sample occurs when individuals respond to a general invitation. So the researcher is basically putting out an invitation to answer a poll. Maybe it's a write-in poll or a call-in poll. Voluntary response bias occurs because of differences between the people who are motivated to respond or not. They systematically overrepresent some parts of the population, those who are passionate, disgruntled, or have strong opinions, and underrepresent others, the people who don't care enough to respond. In voluntary response samples, the researcher does not select the sample. The subjects self-select. The researcher just issues an invitation. It's the subjects that decide whether they are going to be in the sample or not. Convenience sampling occurs when individuals or units are chosen because of accessibility or convenience. In some cases, convenience sampling is the only practical approach, but it leads to undercoverage bias because the sample typically does not represent the entire population. My example of a convenience sample is the man on the street interview. Suppose you ask people outside a country western bar whether they favor gun control. Will the sample result indicate a higher or lower support for gun control than the actual value for the general population? This is a convenience sample. It overrepresents people who are outside the country western bar and underrepresents those who are not. So it is a convenience sample. And of course, the question, will the sample result indicate a higher or lower support for gun control than the actual value for the general population? The answer to that question will tell you the direction of the bias. How about if you stop students on the way out of the cafeteria as a way to find out about the quality of food? Well, this is still bias but this time the bias occurs because the people who were sampled actually chose to eat at the cafeteria. It underrepresents those who, didn't eat at the cafeteria, who found other places to eat. Again, whenever you identify a bias, you have to tell me the direction of that bias compared to the true population value. Another type of sampling is called a systematic sample. It has 2 steps. We randomly select the starting point, then we select every kth item thereafter. What does it look like? Suppose I select a sample of 10 college admission forms from a stack or a population of 83. 83 divided by 10 tells me I should be sampling about every 8.3 admission form, so I select every 8th form. My starting point, I have to choose randomly. I choose a random number between 1 and 8. I chose 6. So the first form I select and read is the 6th form from the top. The second form selected is the 14th from the top. I take 6 plus 8, and that gives me 14. The third form selected is the 22nd from the top. 6 plus 8 plus 8 is 22, and so forth. And I work my way through all of my stack until I should end up with a sample size 10. That is the systematic random sample. Now, they're quick and easy, but they are not random samples. Not every sample of size n has an equal chance to be chosen. So if I start out with the 6th form, then there's 0 probability that the 7th form could be chosen. Systematic samples can produce bias if there is a systematic pattern in the sequence of items from which the sample is selected. Suppose instead of having 83 college applications to read, I had 83 students to sample in my population, and they were arranged boy, girl, boy, girl. Well, if I start at number 6, then I will choose number 6, number 8, or number 14, and number 22. If I keep going following this pattern, everyone in my sample will be a female. So that would produce a biased result. A simple random sample. This is the Cadillac of sampling. A simple random sample is a sample in which every group of a given size has an equal chance of being chosen. It's easy to describe, but difficult to do. There are 2 basic steps to doing a simple random sample. First one, assign an identification number or label to every individual in the population. If I'm making a selection with a random digit table, then all of my labels must have the same number of digits, 0, 1 to 30, inclusive. Or if I have 300 in my population, then I use 0, 0, 1 to 300, and so on. But if I'm just using a random number generator, then I don't have to be so careful about having the same number of digits. The second step is that I use a method to randomly select the desired sample size from the population. The individuals whose ID numbers correspond to those random numbers are then selected for the sample. If I want unique subjects in my sample, then I have to ignore repeated numbers and any numbers outside the range. What's important about a simple random sample here is that you precisely describe the assignment process, the number assignment process, that you give clear instructions on how you randomize, and then that you tell us that you select the subjects whose numbers correspond with that ID number that you've given them. Now, there's a couple devices that you can use to generate random numbers or make a random selection. One way is to use a calculator or a computer with a random number generator. And I'm not going to walk you through the mechanics of that, but I've described how you can do it in Excel or Casio. Another method is to select unique numbers or labels from a table of random digits, moving by chunks equal to the number of digits in the labels. Well, what is a random digit table? Suppose I have this problem right here. Mall hours. The management company of Grapevine Mills Mall plans to survey a random sample of 3 stores to determine the hours that they would like to stay open during the holiday season. Use table D, that's my table of random digits, beginning at line 101, to select a simple random sample of size 3 stores. Well, first thing I have to do is give numeric labels to all 21 stores. So I number them, 01, 02, 03, and so forth. Then I start with the random numbers on line 101 and move 2 digits at a time. So my first set of 2 numbers, that's 19. That's within the range, so Star Jewelers is the first store I pick. 22 is not in the range, I ignore it. 39 is not in the range. 50 is not in the range. 34 is not in the range. 05 is in the range, so I'm going to pick Carter's for Kids as my second store. And I'm going to keep repeating this process until I pick my third store, which is number 13, Mrs. Fields. That's how you select using a random digit table. Another random device that you can use is a hat. This is called the hat method. In this method, we put every individual's name on identical slips of paper, and we put all of those slips of paper in a hat. Then we shake the hat, we mix up the slips of paper, and we draw slips out of the hat until we have the right number, number of subjects that we want. When using this method to describe how you selected numbers randomly, it's important that you mention that all of the slips were identical and that you shook the hat to randomize the slips. I want to distinguish sampling with replacement and sampling without replacement. When an item from a population can be selected only once, this is called sampling without replacement. When an item from the population can be selected more than once, this is called sampling with replacement. When using a table of random digits or any other random number generators, you must ignore repeated numbers when sampling without replacement. Bias. The design of a statistical study is biased if it consistently underestimates or overestimates the parameter we want to know. Variability describes how spread out the values of the sample statistic are when we take many samples. Large variability means that the results of a sampling is not repeatable. Generally, the results from smaller samples are much more spread out than the results from bigger samples. That is, results of bigger samples are less variable than the results of smaller samples. So if you want to reduce the variability in your sample outcomes, increase the sample size. You can think of bias and variability using these targets. Bias means that the results are not accurate. And examples of that are in target A and target C. They're not accurate. High variability means that the results are not precise. That's shown in target B and target C. What we ideally want is low bias and low variability. That's what's shown in target D. How to reduce bias? Randomize. Notice how I say to reduce bias, we use random sampling. Random sampling reduces bias. Do not say that random sampling eliminates bias. Random sampling reduces bias. When we start with a list of the entire population, simple random sampling can produce unbiased estimates. How to reduce variability? To reduce the variability of a simple random sample, use a larger sample. Larger random samples are more likely to give an estimate that is close to the truth. That's our lesson for today. Thank you very much.